If you are an electrical engineer, this video is not for you. This video is for those average electricians who are still confused about the difference between the current and the voltage. This video is for them. But if you are an electrical engineer or you study electrical engineering, stay in the background and add your own at the end of this video in the comment section. I'd like to quickly talk about the differences between the current, the voltage, and the resistance. Electrical engineering, there are three parameters which we normally make use of in our calculation, in our day-to-day activities. And those parameters are the voltage, the current, and the resistance. There is need for the average class electrician to understand what current means, what voltage means, and what resistance means. All of them normally mixed up these parameters. They mix up for current with voltage. They interchangeably used voltage in place of current. For example, when they restore the power supply to their house and the brightness in the bulb is very low, the bulb is very dull, a lot of them used to say we have low current, whereas in that case it is low voltage. We do not have low current but low voltage. So we need to understand what is current, what is voltage, and what is resistance. So I am going to differentiate between them. I want you to follow me bumper to bumper so that you understand it clearly. To start with, let's start with voltage. Voltage refers to the potential difference, that is the potential energy that electric charges in the circuit need to move anytime there is need for them to be pushed from one point to another in the circuit. What do I mean? When you connect your bulb, your load, generally when you connect it to the power supply, to the circuit, this load need electric charges to drive them, for your fan to rotate, for your television to draw pictures, for your radio to produce sound. This effect you are seeing in your electrical gadgets, they are caused by electric charges. It is the electric charges that rearrange themselves either through the gas or in any means to produce picture, to produce sound, to produce heat, and so on. And they need energy to move from one point to another in the circuit. This potential energy they possess is referred to as the voltage. The work that we need to do in moving them from one point to another in a circuit is referred to as the voltage. This voltage is measured in volts. If you want to measure voltage, we use voltmeter. But current, in the other hand, is the rate at which you are driving these electric charges in the circuit. For example, if you connect your bulb to the power supply, happens is that your bulb has some element of resistance and the bulb is going to draw current. So when your bulb wants to draw electric charges, these electric charges will now start moving. There is a force that is pushing these electric charges through your cable or through the conductor in your wire. This force is referred to as electromotive force. It is already at the terminal, waiting to push the current through the conductor you just connect to the terminal. And once you connect the load to the terminal, this force pushes the electric charge or electric charges through the conductor. And the rate at which this charges is now moving, rushing into your load, is referred to the current. So which means for you to have current, electric charges must be rushing or drawn from the terminal down into the load. That is what we call current. At times some load are able to draw 3 amps, 4 ampere, 5 ampere, 6 amperes, and so on. It depends on the rating of that load. So current is the rate at which you draw electric charges. And also, it is possible for you to have voltage without having current. For example, I have power supply at my socket, but no load is connected to it. In that case, I have voltage, but no current. The moment I connect my fan to the socket, the fan is going to draw electric charges, and these electric charges will now be moving in a particular rate. For example, if I put my fan at speed number 1 and the speed is low, the current that is going to rush into the fan will be slow at that time compared to when I put it in speed number 2, which is faster. So when it is faster, the current will continue to be withdrawn at a higher rate. So in that case, the current is now the rate at which the electric charges are being driven through the load from the source. So hope we have gotten that now, that current is the rate at which electric charges are drawn from the terminals of our supply, while the voltage refers to the energy possessed by those charges in the circuit. So it is very necessary for you to understand this. And the resistance on its own refers to the obstacle. If I want to go out now and the door is partially locked or partially closed, I need to force myself through a partially closed door to gain my access. If the door is open wider again, the struggle will reduce because there is wider space for me to move through the door. So that is the resistance. Resistance is like a blockage in the circuit. The current wants to flow, but there is an obstacle along the line. So the electric charges will begin to struggle to have its way through the conductor in the circuit, and that is what we refer to as the resistance. And the more this current struggle in the circuit, the more the charges lose the energy. Don't forget I said they are carrying a kind of potential energy, so they will lose this energy, and this energy will be converted to heat energy. And that is the reason why when you connect a resistance to the circuit, heat energy is produced. It's because these charges, because they are struggling to find their way into the circuit, they will lose part of their energy in form of heat energy. So hope we have gotten this now. Let us now do a small analysis. If I have a load, for example, I have a fan and I connect it to the power supply. So if I put it in at speed number 1, and speed number 1 happens to be the slowest, so it is going to draw little current because the resistance will become wider. There are more coil in that case. So the little current will be drawn, the resistance will be high, current will be low. In that case, the work done in the fan will be lower. So when you put your fan at speed number 2, the resistance will reduce, more current will come in, and more work is done, more energy is driven because there is little resistance that is blocking the current. So that is why the fan blade speed higher. And when you put it in the higher speed, let's say speed number 3, the resistance become lowest and more current is also drawn. So which means the more the current drawn, lesser the resistance. The higher the resistance, the lower the current. So that is what the Ohm's law states. I'm going to come your way next time. In case you do not understand this enough, I can still afford to come up with another video to explain this in details. And those of you who are professionals, you can also add your own in the comment section. I'm going to see you next time. Bye.